Welcome. This is now the third video in the tutorial introduction to Python. This is the lecture series Digital Economy and Data Analytics. My name is Eiko van Vuren. And we have seen in the previous two videos that first of all we have been looking at an introduction to Python, and then we have been going on with respect to the basics of the Python programming language. However, now what we would like to do is that we would like now to go on with, I would say, the more advanced topics with respect to Python. And the first topic that I would like to focus upon here is functions in Python, and sometimes in Python called methods. Well, we should realize that at the moment that we would like to define a function in Python, then we are going to use this def that we have over here. So therefore we can look at a very simple example in which we are going to have a function that takes two different say variables, in this case x and y, and it's going to calculate the product of these two variables, or these two values. Well, then what we're going to start with is of course this def that we have over here. Then we're going to, well, define of course our function, and in this case we are going to call it product. And it's going to take two values, x and y, that we have over here. So we are going to get x comma y, and we are going to get these parentheses over here. We're going to get the double points, and then we have to indent, and we are then going to get return x multiplied by y. Well, take here into account that there is here a difference again with respect to R, because of the fact that in R we do need parentheses. However, in Python that's not necessary. Well, now in this case we can simply call the function by using a print statement, and what we can do then is if we would like to find the product of 2 multiplied by 3, that of course gives us this number 6 that we have over here, but we can get that also by simply printing and then calling product and 2 and 3, and then at that moment in time of course what will be given by the computer is of course this 6 that we have over here. Well, this is of course a very obvious calculation, but we can also do more advanced calculations based actually on this function that we have over here. For example, we can use this function in order to calculate the factorials up to 10. In order to do so, what we can then do is that we can then start a particular list. So we first of all going to define a list in which we are going to store finally our results, but at this moment in time we would like to have it completely empty, and that implies that we are going to write our new list as, well, in fact nothing else as these square brackets with nothing in between. So this actually is a list, but it's completely empty. It doesn't have any elements. Then in addition to that, we are also going to have our result, and we set for this moment in time we are going to set result equal to 1. Then the next thing that we can do is that we can then use a for loop, and we're going to use for I. Here again I is the iterator, and in this case we're going to have I in range. Well, we have already seen range before, but in this case what we would like to do is that we don't want to say start with 0, and therefore instead of using the standard say function range which only has one particular say variable, we now are going to use two different arguments, where the first argument is where we start, in this case with 1, and the last argument that we have over here is where we would like to end. But take into account that at the moment that we write 11, then we still actually stop 1 earlier, so that means that here we are going to produce in fact an iterator from 1 till 10. Well, then on the next line, first of all of course we have these double points, but then in the next line we are going to have our result. It's the same result as what in fact have over here, so we're going to override it, and result is simply equal to the product of I and the result that we have so far. Well, this implies that at the moment that I is equal to 1, well then of course result is equal to 1 as well, because we then just started. and that implies that then the product of these two numbers that we have over here simply is equal to 1 as well. That is indeed the factorial of 1. Well, then the next thing that we could do is that we can look at what happens if I is equal to 2. Well, then take into account that the result then is still equal to 1. That is from the first, say, iteration that we have produced so far. That means, of course, that then the product is going to be 2 times 1 is equal to 2, and that indeed is the factorial of 2. If I is equal to 3, then what we're going to get is that then result is equal to 2. So then we get 2 times 2, 3 times 2, and that will give us 6. And that indeed is the factorial of 3. Well, we can, of course, go on. And, well, this program at least goes on up till 10. But we, of course, would like to store our results. And we're going to do that in our new list that we just have introduced. So we are going to have every time that we are over here, we're going to append our new list by the result that we have so far. That implies that in the end we are going to have a list of 10 different elements, having, of course, including all the factorials up to 10. Well, in order to calculate these factorials up to 10 and to, well, store it into this new list that we have over here, we can write it in this format that we have over here, but there's also another way to do it. And that's the format that we have over here. Here, instead of having these 5 lines that we had before, we have now only 1 line. It's a little bit more difficult to read it, but the idea is exactly the same. We have here a new list, and then we actually define directly the list itself by these square brackets that we have over here, and then we say result is equal to, well, the product of x and result, and then we have 4x in range 1 to 11. Well, both of these codes that we have over here, the 1 line that we have over here and the 5 lines that we have over there, will give us exactly the same list, well, including in fact all the factorials up to 10. Well, I think it's a little bit of a preference which of the two you actually might prefer yourself. I would say I would actually go for this one, but I do know that actually a lot of Python programmers would like to use this one instead. I do think that that is a little bit depending on taste. I would like now to go on, and I would like now to go on to the main function. What we should realize is that for structure, it is highly recommended to use a so-called main function. And even though I'm not that sure whether you have ever programmed in any other language than R before, but there are quite a number of, say, other programming languages, more in particular, especially C and C++, but also Java, they have a so-called main function. What is a main function? Well, a main function is actually the function that is going to be called at the moment that program starts. That means that that main function, even in the case that it's not at the top of your, say, programming list, then it's still going to be the function which is called first at the moment that the program is going to start. And actually in C and C++, this main function is obligatory. Having a main function in Python is not obligatory, so therefore what you can do is that you can just simply start immediately to program, and that is going to be run first. But it is better to actually have this main function instead. But in order to have a main function, we have to do a little bit more than, say, in C or C++. Therefore, we first of all have to write these 2 lines of code that we have over here. The first line of code is obligatory. That is to say that we have here if name is equal to main. At least at the moment that we would like to have a main function, then we need to have this line over here. And then we are going to start a block, and then we are going to have this main function that we have over here, which is going to be called. Well, what we should realize is that this is not necessary to be called main. We could also have called it starting function or something like that. But take into account that it is more common and say better behavior in a sense as a programmer to always call it main. And it implies that if we are going to have these 2 lines of code over here, that we need in fact a particular, say, function in our program list, which is called main, which is then going to be, well, started or called at the moment that program is going to be started. Well, we usually write this these two sentences that we have over here at the end of our program. And then, of course, what we need to do is then to define our main function. Well, we can do many things, of course, but if you're going to look at a very trivial program that actually only prints hello world, then the only thing that we need to have is, of course, def main, and then, of course, is double point, and then we're going to print hello world here as we have done over here. But of course we can do many more things. For example, we could have done all these things that we, for example, have over here. We could have also put that in our main function. Well, there are many good reasons for doing it in this way. Even though it's not obligatory in Python to do it this way, it is very good. And the reason behind that is because of the fact that you should realize that very good programming behavior, or to say good programmers, usually try to reduce the amount of, I would say, global variables that we have. But take into account that at the moment that we simply immediately start the program, like in R, then all the, say, variables that we have outside of functions, they're going to be global variables. And we don't want them. So therefore the question arises, how can we actually get rid of them? Well, that is by immediately starting a function, and that is exactly what happens over here. Here you immediately start a function main, so that implies that everything which is then going to be, well, defined in this function main is going to be local instead of global. That implies that a good, say, structure of a Python program is always going to be as follows. The first thing that we do is that we're going to import the libraries, such as NumPy, but we also will later on see pandas. Then we are going to define the global constants. Then we are going to define classes and functions. Then we are going to have our main function, so based on the previous slide, this function that we have over here. And then finally we are going to have this sentence, if name is equal to main, and then of course this sentence here as well.